Okay, so the activity we're going to be working on here, guys, has kind of two purposes to it. Okay, the two purposes are that we want to gain some experience interpreting and reading climatograms. Okay, that's the things we looked at the end of the day yesterday that use the bars to show us the precipitation by month, and then the line to show the temperature. Not all climatograms are set up like these three, where the precipitation and the temperature are actually separated. Most of them look like the ones that are on the next page here, and they're sharing the same graph. Right? So we're going to have to do some interpretation of the climatograms that we have here. One of the most important things when using these climatograms is to carefully look at the scale. The scale is not the same for every graph. Okay? So you could have a really, really wet area that gets a lot of precipitation that looks the same as a really dry area's climatogram because their scales are different. Okay, so make sure you're looking at the scales, okay, on here. Like, so you got St. John, Newfoundland, and we can see that it's, gets a lot of precipitation, 140 millimeters of rain in some months. Okay, whereas when I look at this one here for Halifax, okay, it's a slightly different scale, and so it looks, that looks a little bit different as a result. If I'm looking at Regina, Saskatchewan, it looks like it's got a month that's almost as rainy as that one in St. John's, except it's not even close. Okay, the scale is completely different. Sorry, it's really small on here, but it's bigger. You can make it bigger on yours. Okay, so it's important that you look at the scale, okay, for the precipitation. Again, same thing here, like Prince Rupert, okay, 350 millimeters, looks just as tall as the 140 meter line on this graph. So make sure you're looking at the scale. Don't just look at the general shape of the graph. Okay. All right. That's the first thing, and the second thing is we want to we want to be able to figure out what factors affect climate, okay, especially in Canada. So what we're going to be looking for are patterns, okay, within these climate graphs. Okay, so I'll explain that a little bit more here in just a minute. So your hypothesis needs to be an answer to this question: what factors affect the climate of an area? Okay, we went over the factors yesterday. Okay, so I would say in your hypothesis, in the if part, you should probably list what factors you think will be most important for Canadian cities. Okay, in terms of factors affecting climate, which ones are going to be the most important, or affect kind of the most cities? The end part of our hypothesis is simply a data comparison. Okay? We're comparing the data, climate data for Canadian cities. Okay? The then part, I want you to predict some of the patterns you're going to see. Okay? So I'll give you one, okay, that you can use. Okay? One of the patterns you're going to see, and you want to mention in the then part, would be that coastal cities are going to tend to have milder, wetter climates. Okay, that's something you can probably say with a reasonable amount of certainty. Okay, you're going to want to predict a few other patterns that you might also see, okay, in your data. Okay, because we know that proximity to an ocean affects climate. Okay, so that's kind of what we're saying there. Okay. This is a lot of data analysis, so you're going to do this in groups to help reduce the amount of work that each individual person has to do. Okay, so what you're going to do is with your group, you're going to look at the climate graphs, and you're going to group them together based on their similarities. Okay, so as you're going through these, you're going to see, like let's say we're looking at these two here, Halifax and St. John, Newfoundland. Are they pretty similar? They're pretty similar. Okay, I would say they probably belong in the same group. Right? If I'm looking maybe at Winnipeg and Regina, their climatograms also look a lot alike, and the scales would confirm that. I would say they probably belong in a group together. And there's probably a few other cities that would have this shape that should probably go in a group with them. So what your first job is with your group, make some classes or make some groups of cities that seem to go together because their climate graphs are similar. Okay? As a guide, you should have at least 5 groups. Okay? Like 5 different groups of cities, at least. I'd say there's a reasonable argument to be made for as high as 8. Okay, but 5 would be the minimum. Right? So you're going to group these cities together. Okay, then this is the part where you have to have group members because this part takes a while. Okay, each group member is going to research the cities in a group. Okay, or some of the cities, and what they're going to research are its location and some of the factors that might affect its climate. Right, so if I'm looking at Regina and Winnipeg, okay, I'm going to be looking them up. I'm going to look up things like, I'm going to look up their latitude. I'm going to look up their altitudes. Okay, I'm going to look up basically all the factors that affect climate, and I'm going to write a short, description of the factors affecting the climate for that city. Okay, so if I was looking at Calgary as an example, okay, I'd say it's about 1,000 meters above sea level. It's about 53 degrees north latitude, something like that. Okay, and then I would say, it's not near any bodies of water, nestled close to the Rocky Mountains, and talk about, maybe write a sentence or two about how that would affect its climate. Do that for each city in the group. Okay, then as a group, you guys can sit down and kind of look at what everyone's written, and then you can decide, okay, these are the main factors affecting climate for this group. These are the main factors affecting climate for this group. Then you can look at it. Are there any similarities? That's the analysis. There's a lot of analysis in this lab, okay? Because there's no procedure, really. Like, we're just doing data analysis for this. It's not really a lab. It's just an activity, okay? So, if we're looking at, okay, what else is expected here? Okay, so the class is going to be divided into groups. You're going to use the climate graphs, these ones as well as the other ones, okay, to try and group cities based on their climate patterns. So we talked about that. In an atlas, you don't have to use an atlas because that's old school. Okay, you got a Chromebook in front of you. Google Earth will work. Okay, or just Google like latitude Calgary. I'll give it to you. Okay, altitude Calgary. I'll give it to you. And then look it up probably on Google Earth. Okay, probably use the satellite version, okay, so you can see any surface features and things like that. Okay, locate the same cities, write a brief description of each one, okay, describe the terrain, the presence of large bodies of water, exactly what I said there a minute ago. Okay, so your analysis is this. With your group, try to group the different climates based on your findings, climate patterns and geography. So you may have a couple of cities that have similar climate features, and you may put them in a group called Atlantic climate, or mountain climate, or prairie climate, or whatever you decide you want your names to be. Okay, but give each group a name that seems appropriate, not group one. Okay, all right. As an answer to this question, discuss the effect of latitude, large bodies of water, ocean currents, and surface features on climate. You'll realistically need between 4 and 7 climate groups. Okay, using an atlas and the results of question 1. So now you've got your groups. Okay, you've got explanations for those groups. Now, okay, I want you to look up with your group. You can do this. Okay, the cities listed here. So Dawson, Yukon. Okay, Cambridge Bay, Northwest Territories, Prince George, British Columbia, Fort Vermilion, Alberta. Okay, Lethbridge, Alberta, Timmins, Ontario, Windsor, Ontario, Ottawa, Ontario, Sept-Îles, Quebec. Okay, Fort George, Quebec, Saint Jean, New Brunswick, and Okotoks, Alberta. And I want you to put them in a group. Okay, in one of the groups you've already made. Okay, kind of explaining why you think they go there.
What do you want us to group?
Pardon me?
How do you want us to group a graph or something?
Yeah, you can make a table if you want, or you can just say group 1 and then list them off and then have a paragraph underneath. It doesn't really matter. Whatever seems most logical to you, I'll be able to figure out whatever you do. Okay? All right, and then you'll have a conclusion. In your conclusion, copy paste your hypothesis, and then you got to talk a bit about what you found up here in your analysis. Okay, what were the main factors affecting climate? Can you accept your hypothesis based on what you predicted? Okay, were the patterns that you predicted present? Okay, things of that nature. Everybody kind of follow what we're doing? So you can see here, the analysis is 15 marks. Okay, there's a lot of analysis here. Okay, so make sure that you've got a good explanation for your groups, okay, and things like that. Do a thorough job.
What is the report section?
That's like when I go through it, are there a bunch of spelling mistakes? Is it hard to follow? Is it grammatically terrible? Things like that.
Overall.
It's kind of your overall mark, yeah. Okay, questions there? All right, so just make sure everybody's kind of got a group here. I mean, you could do this on your own, but it's a ton of work. I wouldn't want that for anybody. Okay, I would say you probably need groups of like between 2 and 4, and you can do a reasonable job of this, so it's up to you. Okay, just make sure everybody's got a group and get to work.